This is the 9-1 video solving quadratic equations by finding square roots. Before watching this video, you should have already covered in class how to calculate square roots. You should know what perfect squares and irrational numbers are, along with the radical symbol, radical expressions, quadratic equations, standard form, and leading coefficients. Okay, here is our first example that I'd like you to write down in your notebook. We're going to be evaluating the square root of b squared minus 4ac when a is 3, b is 10, and c is 6. So if you could jot that down in your notebook and show your work and solve it with me, you'll have something to refer back to when you're working on your homework tonight. So my second step of work, anytime I'm working with an algebraic expression, is to substitute in the values. So I'm going to substitute 10 in for b, I'm going to substitute 3 in for a, and 6 in for c. I'm going to close up my radical symbol there. And before we go any further, I just want to point out this subtraction sign. A lot of students forget to change the subtraction sign to plus a negative. So remember to add the opposite anytime you're subtracting. So a lot of people forget that that's really a -4, not +4. Okay, so in our next step, we're going to think of our rules for anytime we want to do order of operations. So order of operations typically starts with parentheses, which I don't have any. These parentheses up here don't necessarily mean parentheses, they mean multiplication. So my next step in order of operations is to do my exponents. So 10 squared is going to give me 100. And because I don't have any other exponents, I can go ahead and I can multiply these numbers out here. So -4 times 3 times 6, when I multiply that out, is going to give me 72, -72. All right, the only other thing I have to do right now is to add 100 plus -72, and when I do that, I should get positive 28. The only other thing for me to do here is to type that into a calculator and round to the nearest hundredth. I know I need to type that into my calculator because the square root of 28 is not a perfect square. So that should give me 5.29 rounded to the hundredth. That will be my final answer. All right, our next problem looks like this. This problem looks a little bit different because I'm not sure that you're used to seeing this symbol. So the symbol that I'm circling right here, I would read as plus or minus. So if I read this whole problem, I would say 1 plus or minus 2 times the square root of 6, all divided by 4. I'm going to emphasize here that the 2 and the square root of 6 are right next to each other. That's times. So sometimes I like to put a little dot there to remind me that that's the operation. Now, this plus or minus symbol here, what this is telling me is I need to break this expression into 2. So I need to break it into 2 expressions, one expression where I'm adding and one expression where I'm subtracting. So sometimes when I solve these problems, I'll get 2 answers. All right, so I'm going to write my addition problem first. 1 plus 2 times the square root of 6, all over 4. And then my second expression is going to be 1 minus 2 times the square root of 6, all divided by 4. I need to keep in mind the order of operations as I solve these 2 expressions to get the 2 answers. So what I need to do first here is I need to do the square root first. When I calculate the square root of 6, I'm going to get 2.45. So I'm going to round that to the hundredth. So I'm going to rewrite this is 1 plus 2 times 2.45, all over 4. Again, following my rules for order of operations, 2 times 2.45 is going to give me 4.9. So I'm going to put 1 plus 4.9 divided by 4. When I do that, when I add that, I'll get 5.9 divided by 4, and that will give me 1.475, which I'm going to round to the hundredth, and I'm going to put 1.48. This is my first answer. And I got that from taking this first expression here and adding 1 plus 2 times the square root of 6 divided by 4. Now I'm going to go ahead and complete my problem, by doing the subtraction portion of it. Okay, so I should already know some of the values here. So I know that the square root of 6 is 2.45. So I know I can write 1 minus 2 times 2.45, all divided by 4. And I just calculated a second ago that 2 times 4.5 is going to give me 4.9. So I'm going to put 1 minus 4.9 divided by 4. All right, when I do 1 minus 4.9, I'm going to get negative 3.9. So I'm going to put negative 3.9 divided by 4. And when I divide that out, I'll get negative 0.975, which I'm going to round to the hundredth. And I'm going to put negative 0.98. So here are my two answers. Negative 0.98 and 1.4. Doesn't necessarily matter what order you write them in, just as long as you include them both. Our next problem is solving an equation, which is going to be a quadratic equation. We're going to write our solutions as integers if we can. If not, we're going to write it as a radical expression, which we'll talk about in another example. So this problem is x squared equals 16. Thinking back to chapter 8, x squared really means x times itself. So you need to think about what number times itself is going to give us 16. Hopefully everybody's thinking 4, because 4 times 4 is 16. Is there any other number times itself that will give you 16? I hope everybody's thinking negative 4. Negative 4 times negative 4 is also positive 16. So what this tells me is when I have an equation like x squared equals 16, I might end up with two different answers. I need to include both of them in my solution. So to show my work algebraically, I'm going to take the square root of both sides of the equation. This is how I'm going to show it, by putting a radical symbol around both sides. And I'm going to get x equals, now we already decided that the answer is 4 or negative 4. A way to write this a little bit shorter is to do x equals plus or minus, which means the positive or negative value of 4. So you can write your answer either way. Here we've got a quadratic equation that's going to require a few more than just one simple step like our last equation. So I'm going to throw in my railroad tracks here. And just like in chapter 3, my first step or my first goal is to isolate the variable. So to do that, I need to get rid of minus 5. And to get rid of minus 5, I'm going to add 5 to both sides. So I'm going to simplify my equation. 12c squared equals 60. Now, to isolate my variable, to get c by itself, I divide both sides by 12. When I do that, I'm going to get c squared equals 5, because 60 divided by 12 is 5. Now I'm going to refer back up here to my directions for a second. It says write the solution as an integer if possible, which it's not. Otherwise, write the solution as a radical expression. Now I know that the square root of 5, I know 5 is not a perfect square, so when I take the square root of it, I'm not going to get an integer. So I'm going to have to write my answer as a radical expression. So basically what that means is I'm going to take the square root of both sides, and I'm going to write my answer as c equals plus or minus, because as we established in the last problem, you're going to have a positive value and a negative value. So plus or minus the square root of 5. Now if my direction said round my answer to the nearest hundredth, I would type in the square root of 5 in my calculator and round that value to the nearest hundredth. But if it says leave it as a radical expression, I'm going to leave it as plus or minus the square root of 5, just like that. Our last example is 2x squared equals negative 50. Okay, just like our last two examples, I want to isolate the variable. So in this particular problem, I'm going to divide both sides by 2. When I do that, I'm going to get x squared equals negative 25. Now, before you jump to the conclusion that the square root of negative 25 is 5 and negative 5, I want to give you a moment to reflect on this. Can I take the square root of a negative number? The answer to that is no. So this particular problem has no solution. And the reason for it is that no number times itself will give me negative 25. 5 times negative 5 will give me negative 5, or negative 5 times 5 will give me negative 5. But as you can see in these examples here, 5 times negative 5 is not 5 times itself. Therefore, I will have no solution.